Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In this example, I will share another example from the professional engineer exam. So to find the reaction forces, we'll take the moment equilibrium at point A, and from there we'll find the reaction force at point C. So we have two forces acting on the beam, and we have the arms for each load, and finally we can find the Cy, which is 6.4 kilonewton. By force equilibrium, we can find the AY at point A, which is 14.6. To find the horizontal reactions, we can isolate the beam AB. So we found the AY, and now we'll find the AX. Since at point B the beams are pinned, from there we can find, if you take the moment equilibrium at point A, point B, sorry. Yes, so from here we have one unknown, which is AX. We can find it from the forces. Yeah, so from here we found AX, which is 4.8 kilonewton. And summation of forces in x direction will give us minus 4.8 at point B, sorry, point C. So Cx will be minus 4.8 kilonewton. So we found the reaction forces, so we can draw the reaction forces diagram. So we have at point A, and also we have at point C. It was easy. We can calculate this component based on the force we found for 14.6. It's just the sinus and cosinus of the angle we have, similar for the 4.8. It gives us 2.87. So we know these angles. It's easy to be found, to be calculated. So just to simulate, I will take in two sections, moment 1 and moment 2. So for the first one, we have the 12.5, the vertical load. This will be M1, and the arm is 7.5. So here we have 11.68 and 2.87. So you can find the moment exactly at this point. And this gives us 66 kilonewton meter. So similarly at point M2, and point M1 and M2 are where the vertical loads are applied. So, and the arm is at 12.5. Yeah, so if we take moment at point M2, so we have 11.68, and also we have 2.87, and this time we have the contribution from the load 12.5. If you calculate for the perpendicular to the beam, so from it will be the sinus. From sinus it will be 10 kilonewton. So M2 will be 60 kilonewton meter. So we also found the moment along the beam. So here we can draw the moment diagram. At this point we have 60, how much it was, 66. Yeah, so this was the moment diagram. And we have a zero moment for the beam BC. So here we'll draw the shear diagram. So we have the 11.68, and also we have from the contribution from the horizontal reaction force, and also we have two forces from the applied point load on the beam. So these are the perpendicular component from the applied loads 10 and 6.8. So here at this point the force are acting 11.6 and 2.87. This, so the sum will be 8.8. So it's plus. And also at point where we have load 10, so we'll go back to 10, so we have the difference will be 1.2. And again we will have 6.8, so here will be total will be 8. 6.8 plus 1.2 will be 8. So this was the shear force diagram. And we have zero shear on the beam BC. So for the axial force, so these are also the contribution for the two applied loads. And these are also from the reaction forces. This is also pretty straightforward. So this is just for one case it will be the sinus of the angle, for another case it will be the cosinus. And from here we can draw the axial force. So on the beam BC we have 2.8, and also we have 5.2. So total will be -8. So the axial forces are in compression, they are in minus. So here you go, you have all the forces. Results. We'll compare the results with the static program. So here in this case, this is the same length of the beams and the same loads are applied here. So we'll check the reaction forces. As you can see, the 14.6, 4.8, 6.4, and minus 4.8. So if I check the moment, as you can see, 66 here, 6 here, and goes back to 0 there. And also the shear force. So as you can see, 8.8 there, 1.2, 8 there, and 0 there. Also the axial. So yeah, 12.6 minus 5.1, 0 there, and minus 8. So here you have all the loads, and the results correspond with the static program. Have a nice time until the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.